In this acid-base reaction, the first thing I realized is that this lithium will become a spectator ion as it is in the first row of the periodic table. So, the bond between the selenium and the lithium, the electrons went back to selenium, and this extra lone pair on the selenium gave it a negative formal charge. As it had a negative formal charge, that would make it the base, because it's searching for that proton to balance that charge. So if this is the base, we're left with this as the acid, and in a Bronsted-Lowry reaction, the hydrogen gets broken off from this nitrogen. So this bond will go back to the nitrogen, giving another lone pair to this nitrogen, and this lone pair from the selenium will grab that hydrogen in the reaction. So we're left with the products, this conjugate base from this acid, which is now missing a hydrogen and has another lone pair on this nitrogen giving it negative charge, and this conjugate acid formed when the selenium got a hydrogen and balanced out that formal charge. So acid, base, and then conjugate base of this acid and the conjugate acid of this base. So in order to identify the strong acid versus the weak acid, we have to look at the bases. So for this acid, we're going to look at its conjugate base, and for this acid, we're going to look at its conjugate base. So we have to compare the stability of these bases, because a strong acid will have a more stable conjugate base and also a weaker conjugate base. So using the Areo method, we first have to look at the difference in the atoms that have the charge. So in this conjugate base, the nitrogen has the formal charge, whereas in this base, selenium has the charge. So we could compare the electronegativity of these two, where nitrogen is higher on the periodic table, making it more electronegative than selenium. But we also have to take into account the size difference, and selenium is a lot bigger in size than the nitrogen atom. And since it is bigger, when a charge is placed on this selenium, the charge is spread out over a very large volume, but when the charge is placed on this nitrogen, the charge is stuck in a very small volume of space. So even though this nitrogen is more electronegative, this selenium can better stabilize the charge. So I labeled this as the strong acid because it created the more stable base, the weaker base, and this is the weak acid because it created the less stable base, or the strong base. So the acid which I would predict to have a higher pKa value would be the weaker acid, which is this one, because weaker acids have higher pKa values. And to predict the equilibrium position, we have to know that equilibrium favors formation of the weaker acid and base. So equilibrium actually favors this weaker acid and this weaker base. So the equilibrium is shifting left towards the products. And at equilibrium, these two species will be in the highest concentration. And that's about it. Thanks.